Hello everyone. This module we are going to look at the efficiency of Python. The complexity of Python can be measured by big O, but that is by using paper and pencil. Can we compare the two functions or two programs in real execution performance? So one of those, the measurement is to measure the time complexity. So we're going to measure the time. And also that can be analyzed further by disassemble the code. So we'll look at those two things, time complexity using the time elapsed, the measure the elapsed time, and also see the byte code, inside the code. Okay. So here's an example. For example, the exponents. Okay. So that if you want to see 3 to the power of 99, then we can use that. Well, there is a function called power that takes two numbers, x and y, which is 3 to the power 99. Then it will return the same result. Sometimes in our coding, we can use this basic function or was a little bit of the function defined by Python, right? So how can we measure those two things? In order to do that, we can use, for example, time it. So that is a module. So we can use, for example, in this command line, this is Python. If we run Python, then Python 373 is running. So I'm going to quit this and then simply Python, and I'm going to include the module is called the time it. And then I'm going to measure the power 3 to the power 9999. Then I can measure it. Okay. Then it'll return the time. It has how many loops? 50 million loops. It takes 3 nanoseconds. Similar things if we do using the binary code itself, then see how long does it take. This takes a little faster than using the function, right? We can compare that if we add, for example, 2 more 9, 6 nines, okay? See what happens. It takes 9, or still, it's not really too bad. We can do also the same thing. Still better, right? Let's say 2 more 9, 9. Not this, but using function first, okay? So how many nines? 1, 2, 3, 4, 5, 6, 7, 8 nines, okay? That is the exponent. It takes 9 nanoseconds. If we do this, 9. So this is a little better, right? So how can we say why it is better? We can take a look at, we can disassemble it so that we can see why they are different, right? So the way we do, I can do either this command line, or I can come back here because this is already in. So I'm going to use this in order to that disassemble module needs to be imported, and then I can do this dot this. This takes within the quote first power of 3 and 9999. Okay, there should be a close parenthesis. Then what it says is that load the function POW, and then load the number constant, another constant 9999, and then call the functions, right? That is the way that we use this the built-in function. The other way that you can do here without it, we can simply do star star, right? And then we disassemble that, then we can see another byte code. Okay, in this byte code is a lot simpler than previous. Previously, we have to load the function, and then we call that function. Here in this case, no such things. Only take two constant and then run the binary power, right? So this tells us the difference between those two way of using the computation. This is using function. This is simply binary code. All right. So similar things can be done by, for example, our well-known sorting algorithm. Okay. So I have here sorting algorithm. Sorting algorithm that you can do simply run. This is simply the using the function sort, right? And the other one, maybe you can use a quick sort. That's what we have here. And then there are multiple ways of the measuring elapsed time. There is a module time and then time it module. So one time I use simply the clock function in time module, and another time function in time module. So I can start the time function and then check another time. I can compare these two, right? The later time minus the earlier time, then that is elapsed time. Same thing here. Using time it module, I'm using time it functions. All right. Similarly, for that quick sort, so if I execute it, then using sort, it takes, if we use the clock, the system clock, then 1.3 to the power times 10 to the power negative 5. On the other hand, the quick sort, it takes 1.28 times 10 to the negative 5. So in this particular case, quick sort a little faster. But anyway, in this way we can check. Quick sort is our implementation, and then the sort that we here is the built-in function that we use, right? So in this, similarly, we can also these functions to measure and to verify the byte code, why they are similar. If they are a little different, how much they are different. That type of things can be done by this function. So in the module, in here, that you can see the difference, right? For example, from here, we call a sort list, and then using that sort name and call the function in that sort, right? So I want to sort the list. This is the data, right? I have a list 56, 34, 1, 87, 21. So in the given list, I have 5 elements. So how can we sort? We can use this sort of that list. So given that list, I use the function sort list. So this is this is a module, I mean code segment that we use the given functions. See here, this is a function. At each time I use the sort list, right? Another way is a quick sort. And from here, say partition. So given the list, I use the partition. If you use a quick sort, I want you to record the quick sort, and then for each, I mean, take 2 elements in the list, and then partition the list, and then we compare, and then we set the list. Okay, so that is basically what we have done here. That you can see the bytecode.